Hello everybody, good morning, good evening and good afternoon and good night everyone. Welcome to Verona for the live streaming of OMV F37X inline system. I am Antonio Staffoni, the CEO, and here with me is
Stefano Lonardi. I'm the CTO of the company.
So I'm the guy who tells the story, he's the guy who answers the questions. Okay, so first of all, it's a pleasure to have you with us. We are going to show in a moment a brief introduction that we registered yesterday while our colleagues are starting the machine up. And before we get going, let me thank our sponsors. We couldn't do this without their help, and these are TRIA grinders, VISMEC dosing systems, ABB inverter drives and motors, and Bellini Meda boxing and cartoning machines. Okay, so without further ado, please let us go with the introduction. Welcome everybody to the live stream event of OMV. And well, first of all, allow me to take off the mask, because fortunately here I don't have anybody nearby, so I feel pretty safe, and I hope of you too. I hope you can stay safe, especially. I'm alone here, so I can do without the face mask. It's my first time on YouTube, and you know, you got some 150 registered attendees from the Americas to New Zealand, and that's not bad at all. A special thanks to the guy or the guys who are up awake in New Zealand. I hope you're actually doing the night shift, otherwise, you know, you got some bad sleeplessness problem. You need to see someone good. Okay, but let me also extend a very special welcome to our competitors, to their agents. You know, we're delighted to have you with us today. It's, for me, a comforting thought and a proof that, as I always thought, OMV is actually punching a little above its weight when we have such important competitors that keep an eye on us. So let me begin by introducing OMV to those of you who may not know it. OMV is not a big company. We are specialized in inline thermoforming of all thermoplastics and polypropylene in particular. Besides that, OMV tries to be of help to all the players in the industry, in the plastic industry, all those companies who want and need to develop new products, try new materials, and so on. So for that purpose, we have a pretty extensive research and development facility and activity. And in particular, we have a dedicated area, which we call the Tech Center, which is exactly equipped with an extruder and a thermoforming machine. So it's dedicated for extrusion and thermoforming, where our customers can try inline and offline thermoforming on their products. So you can even have your own product specially designed for you, as long as it can be thermoformed. We prepare one-up single cavity tools, and we install it in the test center. This is made on your design, and so you can use this facility also for pilot runs, for pre-qualifications, for pre-marketing purposes. And of course, and most importantly, in case the customer eventually likes the projects, decides to go ahead with it and go ahead with OMV, then, you know, we guarantee that the result on the industrial equipment will be the same or better of the one you got on the tests. So we actually have people using the tech center right now. That's why you may hear some noises around me right now. But obviously, we cannot tell you what they're using it for, as we take our secrecy commitment very seriously. But we'll be able to give you a sneak peek in the tech center in a few moments. Before that, allow me to take this chance to send a message which goes beyond OMV. And it's a message that I in particular, but all of us care a lot. And I think since you are probably, if you're listening to this, you're watching me right now, you are in the plastic industry, so probably you are sort of an easy audience for that. And I think you care about it too. The message is this: plastics is not the devil. there are many ways to make a part, a package in particular. We talk about packages because that's what 95% of our job. And you know, if you're not in the plastic industry, you may think that a part, for instance, made of paper or glass or aluminum is better than plastic because it's more ecologic. Well, you know what? You may be wrong. Let's take an example. So here I have, for instance, paper cups, and here is a plastic cup. Or you could take, I don't know, a paper tray. This is made with a different technology, very nice, but paper, and plastic trays. So you may think that this is more ecologic than this one, because if you throw it in the field, then after some time, you know, it goes back to nature. Well, as I said, you may be wrong. Guess what? The point is, how do we decide if something is more ecologic than something else? Well, there is one thing which is called life cycle assessment. So it's a study made by independent organizations, think tanks, whatever. Some of them are actually run by ecologic companies. And in this study, people consider the various alternatives to make a product, like plastic cup and a paper cup, and they see, you know, how much energy goes into it to produce it, how much energy goes to recycle it at the end of its life, whether it can be recycled, of course, and if it can be recycled nearby, or if you have to send it, you know, across an ocean to get it recycled somehow. So they put all this together, and eventually you get some kind of a scorecard. And that scorecard evaluates the energy, the impact on the atmosphere, if it releases NOx or whatever, chemicals when it is burnt, whatever. And guess what? All the studies I saw actually say that whenever there is a, you know, a scientific comparison, recycled plastics is actually more eco-friendly than paper or metal or glass or ceramic, whatever. Why? Well, paper, for instance, you probably know, is not entirely paper. If you make a paper cup out of a sheet of paper and pour some water in it, guess what? You're going to get wet. So how does that hold? There is plastic inside here. There is typically a polyethylene film. Or sometimes there isn't, but in that case they are spraying, there is some other chemical that basically is hydro-repellent enough and avoids seeping it through. And some of these chemicals are the so-called forever chemicals that, you know, they call them forever chemicals because they stay in the environment, and we might also, they're not really very good if you eat them. You might have seen a movie about it recently on Netflix. All right. So, again, if you agree with me, you guys of the industry who are watching this, please share this video, at least this part. That's why I'm making it right at the beginning. Send it to your sons, daughters, your relatives, your friends, whatever, and let's try to diffuse a bit the reality about plastics. So my message is, don't demonize plastics. You know? It is not Satan. It is not the problem. It actually can be the solution. It can be the solution, of course, if we are considerate and enough, and if we realize that it is a resource, and as a resource, it should not be wasted. Everyone I know in this industry is aware of that, and it is concerned. This industry employs lots of excellent people, lots of technicians, lots of marketing people, administrative, whatever, and lots of families depend on it. So, would it not be really stupid to kill a whole industry and make all these people lose their jobs, all these families, you know, looking for another source of income, when actually we are not producing something bad? What we produce is useful. So give a thought to that too. Let's learn how to keep our environment clean. Let's learn to make the right effort and recycle, reuse. There is lots of effort into that, and guess what? Lots of the effort is actually guided by exactly the large corporates, the big companies that need plastic for their packaging. They are active on that. We are all engaged through the whole supply chain. And by the way, please remember to click like if you like what I'm saying now and what you will see later. That's the first rule of any decent YouTuber. We need a lot of likes. Maybe some of the young kids change their mind, and in future, who knows, you never know, they might buy OMV equipment, and we are all happy then, right? Okay, so back to OMV. Here are some interesting products that we made in over 50 years of history. Most of them are actually quite recent. So we have drinking cups of various types, also very large one. OMV is proud to have some of the biggest and fastest machines to make cups in particular. And actually the very fastest is this one over here, the revolver, and which has been introduced at the K show years ago and is now proudly working in some plants around the world. Then other interesting things, you know, there are things, for instance, that are made on exactly on the line we are going to show, like this drinking cup that I took as an example, like these trays. The machine can also handle trays, like, you know, yogurt cups of various types, various materials, portion cups. So besides that, OMV also has special machines to make lids. This in particular is a very smart lid. It's property and trademark of UVU, courtesy of UVU lids, and you're going to find the link to this company in the information of our video. Another interesting thing you may like, and which can be done on the equipment we are going to show, is this, which looks like a normal cup, but is actually two cups in one. So we call it, I don't know, if it doesn't have a commercial name, we call it cup in cup. So the machine actually makes in one pass both the small and the big cup, and then binds them together with the coining tool that we are going to show. Other things we did are, for new materials, for instance, there are this is a polypropylene version of a square round cup, and the same version made with a new material. This is a bioplastic from a renewable resource called the polyethylene furanate, PEF, and OMV is proud to be part of a European effort to bring this plastic to the real industrial world in the supply chain. The effort is called the Preference, and it is financed by the European Union and by the Bio-Based Industry Consortium. So we are just one of the players in the whole supply chain to make this a reality. You're going to find links to this also in the information page of the YouTube video. Other things we do? Well, in-mold labeling. Things like this. You know, thermoformed IML. So the same machine first makes the container and then actually puts first the label, then makes the container with it. Can be done also on multi-compartment or on other shapes of compartments like this, courtesy and thanks to Hoffman Plastics. So this is, I think, something to make you curious about where we do this stuff, and a lot of the new developments where a lot of these are done. And I'm going to take you now for a sneak peek of our tech center. So let's come and have a look at the tech center. Follow me. Here we have, as far as I know, the only inline system where you can test thermoform products in an industrial scale. Come over. So now we are seeing the tech center from the feeding side. We have 4 elements feeders with 4 gravimetric dosing systems and one more vat for hygroscopic material like PET or PLA. This feeds another system of 4 more, so there's plenty of room to test anything. And from here it goes to an extruder, which is how many diameters? Diameter
Is it D60?
It is 60 millimeters dia. From there, we have an Calander, a flathead, and then the thermoformer, where right now they're running a single cavity cup. And this is the cup we're going to show today live. This one here you see is the tool
to run
not the
in
tool
the line,
we're seeing
which
now,
is now
because that's
installed
already
in the
installed in
line.
the
It's
machine, but
actually
another tool made
112
for the same
cavities
project.
for that
This
small
one is a 60
medical cup.
cavities drinking
And
cup
we're
tool.
going to run the
You
acceptance
see on the
test
left
at
side
28
forming
cycles
tool,
per minute.
and scattered around it.
It delivers
we
a
are going to see
whopping
in a second
188,000
more
cups
details
per
about
hour.
it.
So here, this tool you're seeing now is not that one, because that one is installed in the machine. This is also a tool for the same project. In this case, it is a drinking cup.
Meanwhile, I see we got already 12
And,
likes. Thank you.
You know,
It's
and it
my
has
first time in
all
YouTube.
what it takes to
gives a
rim-roll
nice
it.
feeling to
In
see so many
particular,
likes.
Here is
If you like
the
this,
forming tool,
click some more.
closed in this moment. Over
So
there
here we
you see
go.
scattered around
So
the
over
various
there you see
format
the
parts
cage,
for
you
the pick
see
and place robot, the cage to build the stacks, the belt to deliver it. All these parts are built as format. Over there the extraction plate, which we will see in a moment running, but to pick the parts out of the forming tool or out of the coining press. So let's take a look how the coining press works. So we have the cup, the forming tool will be somewhere here, and the extraction plate, the tool will open, the extraction plate comes, we'll pick it up and bring it to position. So in this point, the coining tool will come up from the bottom and the counter matrix from the top. So the two together are going to close the U-rim and turn it into a very nice closed lip rolling. And that's how we do a coining in line without need of, destacking the parts, going through all those screw rim rolling equipment, and then you have to count and reconstruct the stacks again and so on. So all this you will see in a moment running is done inline, hassle-free, no problems. So this is the rim-rolled medical cup. You can see that this part here, this is as it comes out of the former, and this is how it comes after the coining. So notice how this rim is, how much close it is compared to the U-rim as it comes out of it. This is the way it comes out of a forming tool, and this is how it comes out after coining. If you put the two together, you can see immediately the difference. Notice how much bent, how much more bent is this rim with respect to the other. And now let us have a look at the equipment. Follow me.
Okay, now we're taking a close look to that, going from a drone, and I take this minute to thank again all our sponsors. We start, you see here the big silo where the scrap are coming on your right side. It is of course an inline system, that means closed loop, the scrap is continuously recycled. This instead is the inlet from the Virgin, which for the test today we are just fixing from a big box. This is a detail of a dosing system thanks to VISMEC, who is one of our sponsors today, and the extrusion control system. From there we go down, this is the main extruder, and here special thanks to ABB. The motor and the control systems, the inverter drives are actually from ABB for the extruders. All extruders have multiple zone, temperature zone controlled. We are talking of 3 extruders here, so that we can make ABC and all sort of combination and permutation together. The whole extrusion line is able to provide up to 800 kilogram per hour of polypropylene and 1000 per hour of polystyrene. The three extruders diameter are 120 millimeter, 60 and 45. What we see here now is the screen changer. So there is a guillotine system that allows to move and to change the filter to catch any magnetic impurity or whatever without stopping the stream, the flow of the extruder. Once again a panoramic from the top. And now we're focused on the co-extrusion block, where you see all those numbers. For each of those numbers there are resistors and the temperature controls, which are all controllable by recipe or directly from the operator panel. This here is the flathead with the controlling lip adjustment. The lip adjustment can be made manually, but in this case we have an automatic lip control that comes from a sensor, a thickness gauge sensor that we're going to show in a second. Right now we are looking at the Calander. It is an ice-tech Calander, so the three rollers diameter are 350 for the first and 500 millimeters for second and third. In an inline system, the purpose of the Calander is just to equalize the temperature of the sheet. And the whole game, name of the game, is to have the hot sheet coming into the thermoforming area. That in a moment I will explain how that saves a lot of energy. Here we see the detail from the Haul-off to the sensor. That's the thickness gauge sensor. So this one actually feeds back the signal of the thickness, which is continuously monitored, to the actuator, which you see now on the right hand side, the one we saw a moment ago. And this is the control panel, the HMI, where for the extrusion line in particular you can see all the detailed settings of extrusion line, but also the general settings of the whole line. There are two such HMIs, one in the extrusion area, one in the thermoforming area. Right now this is the oven, so with Elstein ceramic resistors. It allows, of course, the best control for the sheet to come in. The purpose of the oven here is not to heat the sheet, because it's already hot, and especially it's hot from the inside, which is even best for the thermoforming purpose. It is just to make sure that there are no uneven heat on the sheet coming to the forming area, which we see now at the end of the chain links. That one over there is a close-up on the forming tool. And as we mentioned before, it's a 112 cavities tool for a diameter 38 millimeter cup. Up there you see the motor, the servo drive that controls the plugs, the plug assets, and that's again a close-up of the tool. 3 pins by each side for controlling, and that's how as close as we can go.
This is the bench we are going to use to remove the mold from its place. Imagine here we have the press. The press will open. We are going to link and catch the mold by binding it with this frame over here. Activate with a push button. This motor will start the chain and pull the entire mold lower part over here. This is for the lower mold. So it will be here ready in this bench to be brought to wherever you need for maintenance, cleaning, whatever.
Right now we are seeing the coining press. This is where the magic happens of coining and making the lip roll. So this is the part that from the bottom comes up and will coin against the extraction plate. Stefano, would you like to say something about the coining system? Go ahead.
Yeah, coining system is our system to rim roll the cups. It's very useful in order to achieve a good quality, an acceptable quality, without the typical troubles of the screws rim rolling devices. So we don't need to have a perfect lip in order to achieve a good result. It's enough to have an acceptable lip, while when we are rim rolling with the screw system, the system needs to have a very, very good and perfect lip.
Okay, and after coining, we'll see the cups will be extracted from the coining press, moved from that pick and place robot that we just saw on the right to the cage, and then from the cage they will be moved into the belts. Behind the belts we see the soundproof box, which is provided always for a standard, and inside the soundproof box there's a TRIA grinder. This is a detail of the format of the pick and place robot and the detail of the cage. It's more interesting when it's moving. It will be moving in a moment. So here is a close-up of the TRIA grinder, and these are images courtesy of TRIA. Thank you guys. They are showing this particular grinder is a TR series 1400, am I right, Stefano? 11040. Well, I'm going to put the link in the
110/60.
Okay, you're going to have a link in the info box of the YouTube video. So here you see the highlights of what the series of TRIA grinders can do, the ranges and so on. And now these are our guys starting the machine. We see now the extrusion area with the calander, again a detail on the polypropylene, the virgin supply. There we go, the sheet now is good enough to be fed to the thermoformer, and the operators are just cutting it and feeding to the chain. Here we go. The oven kicks in. Chains are moving. For a little while, okay, this is the, how do we call this? Cycle 2.
Cycle 2 in order to heat up the plugs.
So for a while the former will go without, you see up there are formed cups, but we don't go yet, we didn't start the cutting and extraction plate yet. And as soon as they are hot enough, here we go. They are starting the extraction plate and the cutting cycle. So now the machine is running. Every time that thing goes up and down, you get 112 perfectly lip rolled small cups. It's about 2 inches wide. So these are medical cups with the graduation signs on the insert. And we see now the delivering side and the stacks going into the sleeving machine. Sleeve rolling. The sleeves are closed. And from there, here they are reaching the entry side of the boxing machine. The boxing robot is preparing the rows one by one, then they go into an area to fill it, and from there the carton receives the already pre-ready rows and delivers it to the palletization area. Very good. So that was the startup. Now we are looking at the machine running live from our plant, and this is another close-up from top to bottom. Now let us see, any of you can ask questions. I hope you made it. I'm sorry we had to change the link in the last minute. I think some people wrote me about it. I tried to send everyone the link, the new link. I hope you received it. And so let me see a moment here the questions and answer up here. Well, so far there are a few questions which I see our sponsors already answered. What else can we tell you guys? What are you curious about? Thank you, Praveen, for the compliments. Oh, there is a question from Alex Proydan. Hi, Alex. Nice to have you with us. So Alex asks, what is the overall footprint requirement for this line? So that's the reason I have my CTO with me. I'll let him answer.
The line you can see on the screen is 31 meters by around 18 meters. So it's a 31 by 18.
So overall, it's kind of a compact footprint. We have another question from Mr. Omar Abdat. He's asking, what is the maximum draw depth? So what's the deepest cup it can form? And again, I'll ask Stefano to reply to that. And with that, we'll also tell you what is the shortest. This is also good for shallow trays. So Stefano, what can you tell us about it?
The deepest is 150 millimeters in this version. Of course, we can increase it, but it's not in this version. We have an additional version, and of course, the speed in this case will be a little bit less.
And Stefano, how about the shallow? We also made the shallow trays with this machine. Yeah. How shallow can we go?
It's difficult to say exactly which is the minimum depth we can run with this machine, because when we go lower than 40-45 millimeters, we have to consider with attention the stacking of the system, because the problem is in the stacking, of course. In this case, we are running a very, very small cup. It's a 38 millimeter diameter, and the depth of this cup is something like 45 millimeters. So it's 45 is absolutely acceptable. Probably we can go below this value, but we have to take care about the geometry of the cup.
Okay, we have some more questions. We have Mark Boyd asking, who made the packaging equipment? So the boxing equipment is made by Bellini Meda, a company in the province of Bergamo, I believe?
No,
Brescia.
It's close to Brescia.
Close to Brescia, okay.
40 kilometers from Verona.
Sorry.
It's 40 kilometers from Verona. It's Pozzolengo. It's a small town close to Brescia.
And again, special thanks to them. They're helping us today. So Gideon is asking, footprint 31 by 18 meters. Yes, that is correct. And we have Mr. Sriram Joshi, who asked, can we test for IML containers at the Tech Center? You certainly can. We have a special equipment to test IML labels exactly in the Tech Center with the cavity you desire. I take the occasion to mention, anytime you would like us to test a new material or a new product in the Tech Center, just send us. I mean, what we like to start from is from a product drawing, or at least a concept, or sometimes it can also be a sample that you want to reproduce. Sometimes we had nice challenges like trying to, or thermoforming things that are done by injection molding. So a sample like that will be welcome, and then our technician will examine that and we'll get back to you. Usually we come back with questions about, can we take that shortcut or this shortcut? Because as everyone knows, injection molding and the thermoforming, don't allow the same things. Let's see, some more questions. Tamer is asking, can you tell more about cupping cup? Okay, Stefano, you go ahead. You answer this.
It's very simple, Tamer. Is two cups, one inside the other, and the connection between the two cups is made by the coining system, closing one lip to the other. The main reason of this cup is to make insulation between the inside liquid and the end that is keeping the cup.
So Mark He's telling us he likes the guarding around the calendar. Yes, we do take good suggestions and we use them. Thank you. And Gideon, again, Mr. Gideon from Indonesia, he has a question. What is the purpose of the double cap? Okay, it can be used for, basically, the people who contacted us for it and made some trials in the past and also recently, mean to use it for insulation purpose. It could be either if you have a very cold drink or a hot drink. So the air between the inside cup and the outer cup provides natural insulation. So instead of using a carton sleeve or something, you can just have one container, one cup ready for it. Very good. Maybe we can have a closer look now to the coining system again, and I would ask kindly the cameraman if he can go and make a detail of zone 8. So while he's getting ready for that, I'll just repeat the concept. The whole thing about, cupping cup and coining and so on, this is due to the design of the machine. So the design, as you see, doesn't have a tilt mold. It's just opening up and down. This, of course, has a disadvantage on some times, and of course, tilting is not, we know, is not the favored system in the market. But it has also great advantage, and this is an example of that. Thanks to this simple opening, we can just put a press next to it and use it for coining in this case. In other case, this space can be used for punching a hole, or it could be used for additional cooling, for instance. Stefano, when would you recommend, for instance, some additional cooling?
There are some technical products like, for example, yogurt cup or coffee cups, where the accuracy of the forming is a very high demand. So that's the reason to additional cool the material in order to achieve a very, very good quality in the dimensions of the cup. And for example, a flat rim, that is an important thing for yogurt, for example, or some special features for the coffee cup in the upper part of the cup. And another important thing is the coining system is working at the same time of the forming press, so there is not a losing of time, so we can keep a very high speed in the machine. In this case, we are running 28 cycles with the coining. So the coining is not putting a slow cycle in the machine.
Okay, we've got a few more questions coming. This one is from Mr. Salvador Hernandez. Welcome, by the way. So he's asking, does this machine in medical containers comply with all the safety guidelines that may be required by some government agencies? Now, okay, I'm not familiar with all the safety and the guidelines. What I can firmly say is this machine is going to produce medical cups that will go in hospitals of Poland and Germany. So, okay, of course we did not look at that side of the project, but it's obvious that whoever is going to use it has made his homework. So I would expect it does comply at least with German and Polish guidelines. Mr. Israni Sanjay, hello, welcome. He's asking, what would you consider as the kilowatt per hour for the line as shown running polypropylene cups? So this is a question about energy and energy saving. I will give it to Stefano.
Okay, the consumption is related also to the material and the type of product. Talking about this material, so it's a polypropylene, homopolymer polypropylene, and this product, we we have approximately 1 kilowatt per kilo of net products. I'm talking about net products.
Thank you, Stefano. Now the next question from Mr. Abdat. Mr. Ramswarup. Hello, Mr. Ramswarup. Nice to have you with us, long time. So Mr. Ramswarup is asking, is it possible to do IML on the round cups? Again, I give this to Stefano.
That's possible, of course. Our machine is not that machine, it's a different machine, of course. Our machine is able to run IML containers, IML leads, for a butterfly label or for a wraparound label.
Very good. So it's really nice to see you so active. And as I mentioned, we received questions from the Americas, from Europe, from the Emirates, India, Indonesia, Turkey. All this in 30 minutes of live stream. Well, I'm really delighted that you're up and awake. I didn't get questions from the guy in New Zealand, so he's probably sleeping. That's good for him. So, but for any one of you who is going to miss the live stream, as I just typed in the text box in the chat, we are going to give also the link to the streaming. It will stay in our YouTube channel. At any time you can call it up and see. Oh, another question from Mr. Ramswarup. Can this machine do PET fruit punnets with angular holes? Maybe not this one, Stefano, but we have others.
So the machine, I'm talking about the thermoforming machine, is able, of course, to run PET. It's not an issue, of course. The extruder is not the right one to run PET in this configuration. We have to add some equipments. And about the holes, this is another story. So we have to change the rim rolling station with a different station for like a punching station.
Thank you. So while the video is showing again the loop from the top, I'll just take the occasion to remind that okay, there is a striking similarity between these coffee cups and the most famous coffee cup in the US. So medical cup and that coffee cup. Okay, that coffee cup is not a drinking cup, of course. It doesn't need a lip rolled system. There is a whole world of compatible cups out there that may need some kind of punching or holes or whatever. So this machine is definitely, oh, actually, let me not say that. Let's make like they do in the live, in TV. I'll ask Stefano. So Stefano, what do you think? Can this machine be a good choice for everyone who wants to make coffee capsules?
Yes, I think so. In this case, the rim rolling station is not needed, of course. And the diameter, you can see, is very similar to one model of a coffee cup. Now we are running 38, and the very popular Nespresso compatible cups is a 37 millimeter. I think it's a very good choice. A lot of cavities, a lot of production, so that could be a good choice.
So this is actually fun, you know. I might get used to this. And may I ask now the cameraman to give us a close-up of the boxing machine, in particular the area where the rows are formed, where you still see the blue belt. So he will probably take 1 or 2 minutes to get there and be ready. And meanwhile, we have another question. Oh, just a message for the cameraman. This would be zone 11, but from the side where you see the blue belt and the arm pushing the rows. Thank you. Oh, we have a question from Mr. Miltos. Welcome, Mr. Miltos. He's asking, the pick and place system, is it standard with the machine or extra? Is it something developed for those small medical cups?
No, it's our standard system, and it is the same system in the range of OMV thermoforming machine from F33 to F87. So we are using exactly the same system for the smallest machine, F33, for this model, F37X, and for the biggest model of this range, that is the F87. Absolutely standard.
Okay, we are seeing our colleagues busy over there at the end of the delivery side, and the cameraman is moving. Yes, that's exactly the place we want to see, a little bit to the right where we see the arm pushing the stacks. You can maybe, if you could move up to the platform and have a close-up of the arm. Right there, perfect. We can have the image from the camera now, please, on the live stream. The live stream is still showing the cartoning part. Oh, maybe I have some delay now. I have to be patient. Okay, so thank you. This is the system. Just a comment and a brief explanation of the boxing machine. This is a completely stainless steel machine. And what else can we say about it, Stefano?
It's very simple. The machine, the equipment is receiving the sleeves from the bagging machine, preparing the layer to move one to the other in the like a box, and the complete set of layers is moved from this intermediate box to the final box, so to the carton. Very, very simple, fast machine. You can see that few movements.
Yeah, we like it. It's sleek and simple. Oh, I have a question from Mr. Soleiman from Indonesia. I also answered on the chat, but let us say it also on live. So, okay, maybe it was a little confusing in the introduction. He's asking if the machine now is running the medical cup or the cupping cup. No, this one is the medical cup, the small one. So as you see the speed at which the rows are formed, already sleeved, already boxed, and the whole thing goes to pallet. So that's our slogan, from pellet to pallet. And may I ask to the cameraman, thank you for the close-up. Could we go back to the machine, and could you show again zone number 8 with the coining system? Thank you. Meanwhile, we're reaching 50 minutes of live. It's great to have you here. Thank you, Alberto. Oh, Mr. Onan is asking, can you show the cupping cup again? I missed it. Give us, okay, we were not ready for it, but give me a little time, and we'll see what we can do before closing the broadcast.
Okay, I give you just a brief explanation of the system to stack and to manage the cups in this system. We have the forming press, now is on the right side. What is in the camera is the coning press, and we have a carbon fiber extraction plate with the double formats, one on on one side and the other in the other side. And at the same time, we are picking up the cups from the forming press and coining the cups, another set of cups, in the coining press. So the press now is in the camera. On the left, you can see sometimes there is the pick and place robot picking up the cups from the extraction plate. Now is more clear. And moving the cups, the complete set of cups, into like a cage for the accumulation and for preparation of the stacks. After the number of cups is reached, the complete set, so 112 by the number set of cups in the stack, is moved in the secondary cage, and this cage is transferring layer by layer to the final belt. So now we are like at the end of the stack. You can stay here in order to see the movement from this cage to the other one. Now is clear. On the right side there is the first cage, what we call DSA, and on the left there is the second cage, what we call DCU. Okay, now is the transfer from one cage to the other one. The other one is moving in order to be close to the final belt, and every layer is moved from the secondary cage, so from the DCU, to this final belt. In the same time, the machine, of course, is running and is moving in the first cage the cups for the next set of stacks. Talk about production. This machine is able to run more than 180,000 cups per hour.
That's right. Thank you, Stefano. I was going to stress that the speed you're seeing now, 28 cycles per minute, 188,000 and something medical cups per hour in a full hour. And as you see, it's now about an hour we have started it. Let's say 30 minutes we are showing it. It is pretty seamless going. So I would ask our friends that are helping us with the video, Regia, if it would be possible. This was not expected, but we have a question that requests us to go back live. I mean, we are live, but to go back to the meeting room where the speakers are. Can we have again the signal? Oh, perfect. Thank you. Wow, that's fantastic. All right. So this is to answer the question from Mr. David Onan. Can you show the cupping cup again? Because he missed it. Okay. I hope we can see it close enough. Okay. This here is, you know, it looks like it's not easy to see it from over there. Can we have a zoom? So what you see here that looks like a single drinking cup is actually two, one inside the other. So the inner one, of course, is a few millimeters less of diameter than the first one. And this is a PET sample. And this one here is a polypropylene sample. If you see, this one is rim rolled together. So, Stefano, I believe you were explaining before, in the same mold, half the cavities are making the outer cup, and half the cavities are making the inner cup. Then, in the coining stage, first the outer is put down, and immediately after the inner, and then they are coined together. So, you see here, they are coined, you cannot separate them. It just becomes one cup, and it goes straight to the deliveries, leaving, boxing, whatever, finished product. In here, for the purpose of demonstration, we didn't coin them. So this is how they are placed. First comes the bigger one on the coining press, then the extraction plate drops the second one. And then the coining will bind them together, like this. I hope you could follow it. Oh, we have another question meanwhile from Mr. Ben Yehuda. Welcome. So we add Israel to our followers. What will be the output for 70 millimeter drinking cup, and what will be the minimum weight?
The production rate for the 17.3.6 millimeter, that is another mold provided with this line, is more than 130,000 cups per hour. So we have 60 cavities, and we can run between 28 and 30 cycles per minute. The minimum weight is related to the quality you can accept in the rim rolling. To achieve a good rim rolling, the weight for the 200 ml cup, in my opinion, could be something like 2.2, 2.3, 2.4 grams.
Very well. I think I don't see questions for a while now. I think we can just stay again a minute to give you some time if you have some last questions. And then maybe, Regia, you can give back the signal to the speakers. I mean the video. Come here to the big table. Meanwhile, oh, by the way, this is important. OMV did not make any patent search on that cupping cup. It was a development requested from a customer of ours years ago. Then another one asked for a similar development with slightly different characteristics. So we do not make patent search and patent analysis. We just do the development from a technical point of view, and obviously, so this is a disclaimer. So you may want, before jumping on it, to check if anybody has already patented this system. To my knowledge, there isn't in the market, but it is always possible that somebody has patented something similar. Then the question becomes, okay, is that patent strong enough, or is it valid, or whatever? This is not OMV's business. But we are here to help to sort out all the technical issues that may be there with thermoforming. Okay, thanks. We are back to the main room. And I see there were no more questions right now. I think we are just hitting 1 hour of live right now. So, well, we are really delighted. Thank you so much for being with us today. And we hope we will have soon the chance to meet in person soon enough again, that this COVID craze will finish. It has been a very difficult time for all of us, and yeah, we are close to everybody, to our people and to you guys over there for all the difficulties we all had in this period. But Christmas is coming up, so Christmas brings joy in our tradition and hope, and as a little thanks and a little bonus for those who had the patience to be with us until now, we are going to leave you with our warmest greetings with these nice pictures from Verona and a little dancing for your eyes. Thank you and goodbye. See you soon in Verona.
Bye. Bye-bye.
Jingle bell, jingle bell rock. A jingle bell swing and jingle bells ring. Snowing and blowing bushels of fun. Now the jingle hop has begun. Jingle bell, jingle bell rock. A jingle bells chiming, jingle bell time. Dancing and prancing in Jingle Bell Square. In the frosty air. Jingle bell, jingle bell rock. Jingle bell chiming, jingle bell time. Snowing and blowing bushels of fun. Now the jingle hop has begun. What a bright time, it's the right time to rock the night away. Jingle bell time is a swell time to go gliding in a one-horse sleigh. Ride